the transition from cell to human being. In the functional processes alluded to in the preceding chapter, the male germ cell and the female germ cell unite in a practically equal division of substance. We say practically because the maternal and the paternal influences are not equally divided in the offspring. One or the other usually predominates. But as a general rule, it may be said that in the development of the embryonal life, the process of cell division proceeds in such a way that every germ of the child's future organism represents approximately 1/2 maternal and 1/2 paternal substance and energy. In this process lies the true secret of heredity. The inherited energies retain their full measure of power, and all their original quality in the growing and dividing chromosomes. The chromosome is one of the segments into which the chromoplasmic filaments of a cell nucleus break up just before indirect division. On the other hand, the egg substance of the female germ cell, which is assimilated by the chromosomes, and which is turned into their substance by the process of organic chemistry, loses its specific plastic vital energy completely. It is in the same way that food eaten by the adult has absolutely no effect on his qualitative organic structure. We may eat ever so many beefsteaks without acquiring any of the characteristics of an ox. And the germ cell may devour any number of egg protoplasma without losing its original paternal energy. As a rule, a child inherits as many qualities from its mother as from its father. Determination of sex. Sex is determined after conception has taken place. At an early stage of the embryo, certain cells are set apart. These later form the sex glands. Modern research claims to have discovered the secret of absolutely determining sex in the human embryo. But even if these claims are valid, they have not as yet met with any general application. Early development. Some 12 days after conception, the female ovule or egg, which has been impregnated by the male spermatozoon, escapes from the ovary where it was impregnated, and entering a tube, fallopian, gradually descends by means of it into the cavity of the womb or uterus. Here the little germ begins to mature in order to develop into an exact counterpart of its parents. In the human being, the womb has only a single cavity, and usually develops but a single embryo. Twins. Sometimes 2 ovules are matured at the same time. If fecundated, 2 embryos instead of 1 will develop, producing twins. Triplets and quadruplets, the results of the maturing of 3 or 4 ovules at the same time, occur more rarely. As many as 5 children have been born alive at a single birth, but have seldom lived for more than a few minutes. Gestation. The development of the ovule in the womb is known as gestation or pregnancy. The process is one of continued cell division and growth, and while it goes on, the ovule sticks to the inner wall of the womb. There it is soon enveloped by a mucous membrane, which grows around it and encloses it. The embryo. The primitive trace, a delicate straight line appearing on the surface of the growing layer of cells, is the base of the embryonic spinal column. Around this, the whole embryo develops in an intricate process of cell division and duplication. One end of the primitive trace becomes the head, the other the tail, for every human being has a tail at this stage of his existence. The neck is marked by a slight depression, the body by a swollen center. Soon, little buds or pads appear in the proper positions. These represent arms and legs, whose ends finally split up into fingers and toes. The embryonic human being has been steadily increasing in size meanwhile. By the 5th week, the heart and lungs are present in a rudimentary form, and ears and face are distinctly outlined. During the 7th week, the kidneys are formed, and a little later, the genital organs. At 2 months, though sex is not determined as yet, eyes and nose are visible, the mouth is gaping, and the skin can be distinguished. At 10 weeks, the sexual organs form more definitively, and in the 3rd month, sex can be definitely determined. The fetus. At the end of its 4th month, the embryo, now 4 or 5 inches long and weighing about an ounce, is promoted. It receives the name of fetus. Hairs appear in the scalp. The eyes are provided with lids. The tongue appears far back in the mouth. The movements of the fetus are plainly felt by the mother. If born at this time, it lives but a few minutes. It continues to gain rapidly in weight. By the 6th month, the nails are solid, the liver large and red, and there is fluid in the gallbladder. The 7th month finds the fetus from 12½ to 14 inches long, and weighing about 55 ounces. It is now well proportioned. The bones of the cranium, formerly flat, are arched. All its parts are well defined, and it can live if born. By the end of the 8th month, the fetus has thickened out. Its skin is red and covered by a delicate down. The lower jaw has grown to the same length as the upper one. The convolutions of the brain structure also appear during this month. Placenta and umbilical cord. During gestation, the unborn infant has been supplied with air and nourishment by the mother. An organ called the placenta, a spongy growth of blood vessels, develops on the inner point of the womb. To this organ the growing fetus is moored by a species of cable, the umbilical cord. This cord, also made up mainly of blood vessels, carries the blood of the fetus to and from the placenta, absorbing it through the thin walls which separate it from the mother's blood. Only through her blood can the mother influence the child, since the umbilical cord contains no nerves. The umbilical cord, attached to the body of the child at the navel, is cut at birth, and, with the placenta, is expelled from the womb soon after the child has been born. Together with the placenta, it forms a shapeless mass, familiarly known as the afterbirth, and when it is retained instead of being expelled, is apt to cause serious trouble. Childbirth or parturition. At 9 months' time, the fetus is violently thrust from that laboratory of nature in which it is formed. It is born, and comes into the world as a child. Considering the ordinary size of the generative passages, the expelling of the fetus from the womb would seem impossible. But nature, during those months in which she enlarged the womb to hold its gradually increasing contents, has also increased the generative passages in size. She has made them soft and dispensable, so that an apparent physical impossibility could take place, though it is often accompanied by intense suffering. Modern medical science has made childbirth easier, but the act of childbirth is usually accompanied by more or less suffering. Excessive pain, however, is often the result of causes which proper treatment can remove before and at the time of confinement. Twilight sleep. The so-called twilight sleep, a modern development, by which the pangs of childbirth are obviated by the administration of drugs or by hypnotic suggestion, has its opponents and defenders. The advantage of a painless childbirth, upon which the mother can look back as on a dream, is evident. The twilight sleep process has been used with the happiest results both for parent and child. Opponents of this system declare that the use of powerful drugs may injure the child. A method commended is the administration of a mixture of laughing gas and oxygen, which relieves the mother and does not affect the child. The newborn infant. The average weight of the newborn child is about 7½ pounds. It is insensitive to pain for the first few days, and seems deaf, since its middle ears are filled with a thick mucus, for the first 2 weeks. During the first few days, too, it does not seem able to see. The first month of its existence is purely automatic. Evidences of dawning intelligence appear in the 2nd month, and at 4 months it will recognize mother or nurse. Muscularly, it is poorly developed. Not until 2 months old is it able to hold up its head, and not until 3 months does voluntary muscular movement put in an appearance. The newborn's first self-conscious act is to draw breath. Deprived of its usual means of supply, it must breathe or suffocate. Its next is to suck milk, lest it starve. Heredity. We often find children who offer a striking resemblance to a paternal grandfather, a maternal aunt, or a maternal great-grandmother. This is known as atavism. There are many curious variations with regard to the inheritance of ancestral traits. Some children show a remarkable resemblance to their fathers in childhood, others to their mothers. And many qualities of certain individual ancestors appear quite suddenly late in life. Everything may be inherited, from the most delicate shadings of the disposition, the intelligence and the willpower, to the least details of hair, nails, and bone structure, etc. And the combination of the qualities of one's ancestors and heredity is so manifold and so unequal that it is extremely difficult to arrive at fixed conclusions regarding it. Hereditary traits and tendencies are developed out of the energies of the original conjugated germ cells throughout life, up to the very day of death. Even aged men often show peculiarities in the evening of their life, which may be clearly recognized as inherited, and duplicating others shown by their forebears at the same period of life. As has already been mentioned, every individual inherits, generally speaking, as much from his paternal as from his maternal progenitors. This in spite of the fact that the tiny paternal germ cell is the only medium of transmission of the paternal qualities, while the mother furnishes the much larger egg cell and feeds him throughout the embryonic period. The engram. An interesting theory maintains that the external impressions made upon an organism which reacts to them and receives them might be called engrams or inscriptions. Thus the impression of some object we have seen or touched, let us say we have seen a lion, may remain engraved on our mind as an impression. Hence every memory picture is one of engrams, whether the impression is a conscious one or an unconscious one. According to the same theory, the reawakening of an older impression is an ekphory. Some new stimulation may thus ekphorate an old engram. Now, the entire embryonal development of the human child is in reality no more than a continuous process of ekphoration of old engrams, one after another. And the entire complex of our living human organism is made up entirely of these energy complexes engraved on our consciousness or subconsciousness. The sum total of all these engrams in a living human being, according to the theory advanced, is given the name of nema. That which the child receives in the way of energies contained in the germ cells from its ancestors is his hereditary nema, and that which he acquires in the course of his own individual life is his acquired or individual nema.